This is the test tree from the series, and this test is mainly based on measuring instruments only. So those who did the test can gain a great knowledge and exam level knowledge, right, for the measuring instruments. So if you score a good mark on that, you will definitely be able to get the mark for the A level as well. There will be a one question, one MCQ from measuring instruments, one or two MCQ there might be, and there can be a structured essay question as well, only from this unit. So good work those who did the test, and you can correct yourself after watching this video, and you can correct your mistakes. Other thing is, as you have noticed, the results just came out, and you can clearly see there are two groups of students. One group is A students group, other group is F students group. A students group, F students group, and you can see there's a huge fight going on these days, especially among teachers. Everyone wants a piece of the success of A students. Huge demand on those students, and everyone wants to claim, I did that, I did that. So that's the reality of the situation. So there's a huge demand for those students, A students, and this F students group, they are kind of like ignored. So those are the two groups, and you have to decide which group should you be in. By the next year, you will be categorized into one of those groups, depending on the work you did these days, actual work. You will be categorized either on A group or either on F group. So decide now which group should you like to be in. That's it. So that's about the results and the situation these days, right? That's the reality of actually life. Okay. Then we'll move on to the first question. Okay, first question. Least count of a standard meter ruler is. Least count means the smallest value that can you measure, that you can take from a measuring instrument. So this is a meter ruler. So everyone has seen a standard meter ruler, right? So that is calibrated in millimeters, small millimeters, calibrated in millimeters. So 1 millimeter is the least count. It is obvious. So it is not 0.5 millimeters. You cannot measure 0.5 things using a standard meter ruler. So the answer should be fifth one for the first question. Fifth one for the first question. Right. Second question. 10 vernier scale divisions coincide with 9 millimeter of main scale. If length of one division of main scale is 1 millimeter, least count of measuring instrument is. All right. So this is like a kind of like a standard question, but this can, using this, we can explain the fundamental of vernier principle. Okay. So many students, since many students don't understand this clearly, I'll just explain from kind of small amount of theory parts there. Okay, so in the question what they say is this is the main scale. Let's say this is the main scale, and it is measured in millimeters. So this part of a length of a one part here is millimeters. There are 9 such parts. So the total length of these is 9 millimeters. From here to here, total length is 9 millimeters. So this is the main scale. Right? So main scale is calibrated in millimeters. So one part is 1 millimeter. There are 9 parts, so the total length is 9 millimeters. So in the question they say that 9 millimeter length is divided into 10 parts. So this has 10 parts. 1, 2, 3, 4, 5, 6, 7, 10 parts, right? So what's the length of one of these part? in the vernier scale. Total length is 9 millimeter divided into 10 parts. So 9 millimeter divided into 10 parts. What is that? 0.9 millimeters. So the length of one part here is 0.9 millimeters. So every part, it has the same length. So one part is 0.9 millimeter. One part in the main scale is 1 millimeter. Other one is 0.9 millimeter. Right? So what they ask is least count. So do you see the difference here, like between 0.9 and 1 millimeter? So the difference here is that small value. 1 millimeter minus 0.9 millimeters. So what do you get? 0.1 millimeter. So do you realize, in order to coincide this first mark, you need to move this vernier scale 0.1 millimeter. Then this part would coincide. Right? Likewise, there will be a 0.2 parts here. So that small movement is the least count in the vernier scale, right? You can think about this again, right? Then there's a 0.1 gap here, 0.2 millimeter gap here, 0.3 millimeter, 0.4 millimeter. Likewise, that gap increases. So as you move the vernier scale, those two gaps would coincide. Then you can get the measurement. But here what they ask is least count. So least count is actually 0.1 millimeter. So there's this equation. You can always apply this equation in order to find least count. You don't have to draw these. You can just apply this equation to find the least count, right? So I'm explaining this too much because the remaining questions are also is based on least count, right? Most of the questions, right? So here least count is equal length of a one part of main scale minus length of a one part of, this is vernier scale, not main scale. Main scale division minus one part of vernier scale division. Okay, so that difference is equal to the least count. You can always use this equation. So what's the length of one part of main scale? That's a 1 millimeter, obviously, right? Main scale minus length of one part of vernier scale. So how do you find that? 9 millimeter length, this is the 9 millimeter length, is divided into 10 parts in the vernier scale. Okay, so what do you get? 1 minus 0.9, 0.1 millimeters. This way you can find the least count. Okay, so the answer is third one. So for the vernier scale least count is 0.1 millimeter. For the main scale least count is 1 millimeter. Understood? For the using the main scale, you can only measure up to a 1 millimeter accuracy. But using a vernier scale, if you use like both, that's a vernier, you get an accuracy of 1/10 of a millimeter. Okay. Right. Third question. Using a vernier caliper with least count 0.1 millimeter, 2 centimeter is measured. Percentage error is, okay, percentage error. So you need to know the equation for percentage error. Percentage error. What is the equation? Least count or else we call this maximum error also, right? So it's always least count divided by the measurement taken. Since it is percentage error, you need to multiply by 100%. If you don't multiply 100%, this just becomes fractional error. Only this part we call fractional error. But when you multiply it by 100%, it becomes percentage error, right? So you can clearly see if you increase measurement, so if you are taking a large measurement, right? That's what it means to increase this. Percentage error decreases. Got it? So these are like extra things, but not related to the... So you know that when you are taking a measurement, percentage error of that measurement should always be less than 1%. Less than 1%. Got it? So you always have to calculate the percentage error whenever you are taking a measurement, whether that measuring instrument is suitable to take that measurement. Okay? Right. I will move on to the question now. So they say the least count is 0.1 millimeter. Measurement is 2 centimeters. Meaning 20 millimeters should be the same units. So millimeters cancels off. So this is 1 over 200. This is 1 over 10. So 1 over 200 means, let's say 25. There are 5s. 5 times 0.1, 0.5. Right? So what we got 0.5 of percentage error when you are doing a measurement of 2 centimeters. So according to this, can we use this? Is it suitable to use this? Do this measurement like using a vernier caliper? Can we measure 2 centimeters? So percentage error is less than less than 1%, right? That is 0.5. So obviously we can use a vernier caliper to do a measurement of 2 centimeters, right? So the answer is fourth one. Right, fourth question. Length of division of main scale of a measuring instrument is 0.5 millimeters. 0.5 millimeters. And such 99 numbers of divisions are divided into 100 vernier scale divisions. Least count of the instrument is. So we'll just use the previous equation. Least count is equal to what? Length of main scale part minus length of vernier scale part. I'll just briefly write like that, right? So what's the length of a main scale part? Here it is not 1 millimeter, right? They say main scale has 0.5 millimeter parts. So this is 0.5 millimeters. So when you are doing these questions, I suggest you to substitute with the units. If it is millimeters or centimeters, you substitute always with the units, right? Because sometimes a millimeter and centimeters could mix up. So use units, right? Right, here 0.5 millimeters. So this is the length of a main scale part. Then we need to get the length of a vernier scale part. So in the vernier scale, what they say? 99 number of main scale divisions. So 99 number of main scale divisions. So one division is 0.5 millimeter in the main scale. 99 of those is divided into 100 vernier parts. Ready? So this is the length of a vernier part. Understood? This length is divided into 100 parts, as in vernier scale. So this is the length of a vernier scale part, right? Then you just have to do the simplification. I'll just take 0.5 millimeters out. So inside it is 1 minus 99 over 100. What is this? 100 minus 99, so it is 1 over 100. So just put, so when you divide this by 100, you just put 2 zeros here. So what do you get? 0.005 millimeters. So it has a very small least count, right? 0.005 millimeters. So when you have a vernier scale, this kind of a vernier scale is not available in your school's lab. So when you have a vernier scale like this, so in the school lab, least count is 0.1 millimeter, right? So as you can see here, this one is very small. Since these parts are like very closely packed together, like there are 99 parts divided into 100 parts, so almost you cannot see the gaps here. So whenever you have to use a vernier scale like this, there will be lenses, convex lenses right above those parts. So you will see enlarged image of those, right? That's an extra point. Okay, so this is how you do that question. So the answer should be fourth one there. Right, fifth one. In a spectrometer, circular scale is calibrated with divisions half degrees. 14 divisions of main scale divided into 15 divisions in the vernier scale. Its least count is. Okay, so this also is vernier, so you can use this equation. So about spectrometer, you haven't learned that still. You will learn that when you are doing optics. When you are learning optics, you will learn there's a whole section for spectrometer. So you need to have a spectrometer to do those experiments. You will learn that in optics, right? But that spectrometer also has a circular vernier scale. It is a circular vernier scale that can be used to measure the angles. Right. On to the question. So as they say, circular scale is half degree, meaning the main scale has half degree angles. So it is like a circular scale like this, right? So it also has a main scale and a vernier scale. So let's say this main scale, this gap is a half degrees. This whole thing is 1 degree, but it also is divided into 2 parts. There are parts like this, half degree parts. So the length of a one part is half degree, or angle of a one part is half degree. Then there's a vernier scale here, right? It is similar to the previous questions. The only difference is it is circular now. There's no any other difference. So length of a vernier part is half degrees minus. So in the question say 14 divisions of main scale. So what's the total angle of the main scale? 14 times 1 over 2 degrees. This amount of angle in the main scale is divided into 15 parts. So this has 15 parts here. 14 parts here is divided into 15 parts in the vernier scale. So one part of the vernier scale is this much. Then just do a simplification. I'm taking this half out, right? Then inside it is 1 minus, when you take half, it becomes 1 minus 14 or 15 times 15 minus 14, so it is 1 over 15. What do you get? 1 over 30 degrees. So 1/30th of a part. So the answer should be fifth one, right? Answer should be fifth one, 1/30th of a degree. So what is this? 1 degree is divided into 30 parts. 1 degree is divided into 30 parts. So that is around 2 minutes, right? 2 minutes. So when you divide this into a 60 parts, it is a 1 part. I mean 1 minute. When you divide a degree into 30 parts, it should be 2 minutes. Okay. So anyway, the answer is fifth one. So 1/30th of a degree. Right. Sixth question. In a measuring instruments, capital N number of main scale divisions is divided into simple n number of divisions of vernier scale. Least count of the apparatus by units of main scale is. Right. So the same equation, right? So let's say a unit of main scale is like unit 1. So I'll just, so length of a one part is just 1, right? So let's say the unit is 1. So this is the length of a one main scale part. Then that capital N number of main scale divisions. Capital N number of main scale divisions is divided into simple n. Simple n number of vernier scale divisions. So minus, what is the length of a vernier part? So the total length of the vernier parts is 1 times capital N. 1 means unit of main scale, right? Such capital N parts divided into simple n parts, as in the vernier scale. Okay, when you simplify this, this is the least count. Correct? So the answer should be third one. Right. Seventh question. Image shows main scale and a vernier scale of a measuring instrument. Reading shown by the image is in centimeters. Is, right? In centimeters. Note that least count is 0.1 millimeters. Okay, so this is kind of like a vernier scale, vernier instrument available in the lab. Right. Now clearly understand this. Still, many students don't know how to get a vernier reading correctly. So I can explain using this example. Right. So a reading from a vernier caliper is equal to part of the reading can be taken using main scale only. Main scale only. Okay. So why do we use vernier? When we don't have the enough accuracy, we go for the vernier reading. So the reading from the vernier caliper is main scale reading plus vernier scale reading. Okay. That's the equation you use to get a reading from a vernier caliper. Okay. That's the first step. Then the second step is you need to figure out zero mark of the vernier caliper. in some cases they draw this like this, right? Zero mark here. So it is not zero here, right? This is not zero. When they draw it like this, zero mark is this one. Understood? Zero mark is this one. So don't mistake zero mark as this one, right? So you will get a completely different answer if you get zero mark like that. Okay. There are some tricks they use. So different vernier calipers have different shapes and forms, right? So you should be able to identify zero of the vernier scale first. That's the key point. But what's the difference here? When you think about this is the fifth mark, right? 1, 2, 3, 4, 5. They're like in the image 1, 2, 3, 4, 5. Our fifth one is here, right? So when you mistakenly take like a 1 division, then you get a different answer. In the image, it is drawn clearly, right? Actually, there's 1, 2, 3, 4, 5. So this is the middle of the vernier scale. So this is like fifth point, right? So where is the zero? Is not this one. This is not the zero. Zero is actually this part. How do you know that? This is 4, 3, 2, 1, 0. So this is the zero part, zero division. Got it? So everything is measured depending on this zero mark. Okay. Right. So from the main scale, you can measure up to this zero mark. Right. So this is 8 centimeters, 9 centimeters. So right in between it is 8.5 centimeters, right? This has 5 parts, 8.5 centimeters. But you can read up to 8.6 centimeters. Right in front of zero mark, zero division. So that becomes 8.6. You can read up to 8.6 only using the main scale, 8.6 centimeters. Understood? But there's a slight addition needs to be done that can be read by the vernier reading. So how do you find the vernier reading? Vernier reading is like this. Number of coinciding division times least count. You can always use this. So when you're substituting values, you always use units, right? Apply units. Otherwise, centimeters and millimeters, you might mix them up. So this is 8.6 centimeters. So number of coinciding division. So where do you see a coinciding? In the image, in the paper, it is clearly can be seen at 1, 2, 3, 4, fourth part, right? Fourth division coincides with the main scale. Fourth division. So number of coinciding division is fourth. What's the least count? 0.1 millimeter. But I can write it as in terms of centimeters. So you need to divide it by 10. So it becomes 0.01 centimeters. 0.1 millimeter divided by 10 in order to make centimeters. Convert into centimeters, right? So it becomes 0.01 centimeters. Then it is a simple calculation. So this is 0.04 centimeters. Then if you add those two, it becomes 8.64 centimeters. Correct? So this is the correct procedure to find or read any type of vernier scale. Okay. Sometimes it is tricky to get this 0 mark of the vernier scale. So be careful when you are choosing, when you are identifying 0 mark of the vernier scale. That is very important, right? Other one students get wrong is when they are doing these unit conversions. So you have to carefully convert these units. So always put units, then you won't mix that up. Okay. So the answer should be 8.64, third one. Right. Eighth question. 49 millimeter length of main scale is divided into 50 vernier parts. The measurement shown is 6.048 centimeters. So this is there's a measurement taken, right, using a vernier caliper. I'll better write this in millimeters. So how do you convert this into millimeters? Just multiply by 10, right? So this becomes 60.48 millimeters. So what they ask is the number of vernier parts that coincide for this measurement. And they'll have given the least count as 0.5 millimeters, right? Okay, so many students have found this somewhat hard. Okay, we'll see how to do this. So the previous one, what did I say? Reading is equal to what? Main scale reading plus vernier scale reading. So when you observe this measurement or the reading, when you observe this reading, what do you see? Up to where can you measure just using main scale? Up to 60 millimeters, right? Can you measure decimals of millimeters using main scale? No, right? The least amount you can measure is a 1 millimeter only using the main scale. So it is obvious that this part is measured using main scale, and this part is measured using vernier scale. That's the first thing you have to remember. Okay, so main scale reading is 60, obviously. Let's say 60 millimeters. Then vernier scale reading is what? Vernier scale reading, that is 0.48 millimeters. Got it? Then this part is measured using vernier scale. So what's the equation to find the vernier scale reading? I'll say V. So vernier scale is least count times coinciding division. Number of coinciding division in the vernier. So from this one, vernier reading is 0.48 millimeters. Least count they have given as 0.5 millimeters, meaning half millimeters. So I'll say number of coinciding divisions as capital N, N dash. So this number coincides with the main scale, right? So what do you get? The 0.5 millimeter is in the main scale, right? So you don't know the least count yet. You need to substitute not the least count of the main scale, you need to substitute least count of the vernier scale, right? So they have given values to find the least count of the vernier scale. How do we find that? LC of vernier scale. So the question says half millimeters. This is the length of a main scale part minus such 49 millimeter part is divided into 50 vernier parts. So length of a one vernier part is this much. Then take 50 as the common denominator. Then this becomes 50 minus 49. So this is 1 over 50 millimeters. So this is the least count of the vernier caliper. You have to substitute not 0.5. You need to substitute least count of vernier. So it is 1 over 50. Got it? It is 1 over 50. So just multiply the other side by 50. 50 means 100 divided by 2, right? So you get 25 as n dash. Sorry, 24. 24 as n dash. So the answer should be third one for that. Answer is third one for that. Okay, so these are the steps. So this is this could be somewhat complicated, but this is not that. So first you identified the main scale reading, right? Main scale reading is 60. The remaining part should be measured using a vernier scale. Another thing, so that is identified. So the vernier reading is 0.48 millimeters. So that vernier reading, we know that vernier reading is equal to what? Least count times number of coinciding divisions. So what they ask is actually number of coinciding division. So which division could coincide with the main scale when you are taking this measurement? That's what they ask. So I'll say that n dash. So n dash is equal to least count times the vernier reading. So here previously mistaken, this is not the least count of the main scale. This should be the least count of the vernier scale. So vernier scale least count, you have to find that using the given data. So these are the data, right? Half millimeter is the main scale least count minus. So to find the least count of vernier, not the least count, I mean length of a vernier division, vernier part, 49 millimeter parts is divided into 50. Then you just do this simplification. So then you get 1 over 50 millimeters. Then you can substitute it here. Okay. So when you multiply, cross multiply by 50, you get 48 parts. So the 24th part. So the 24th part, I mean 24th division of vernier scale coincide with a part in the main scale. I mean division of the main scale, right? So if you didn't understand clearly the first previous question, please watch that again, right? And if you have further questions, you can ask me on that. Right, 9th question. When external jaws of a vernier caliper touch, its arrangement is shown by the image. What is the zero error? And they say least count is 0.1 millimeters. Right. So external jaws means these two, the vernier scale. So when these two touch, what should be the if it doesn't have any errors, so if this is main scale and vernier scale, 0 of main scale should coincide with 0 of vernier scale. But what has happened is it is not coincided. Here as well, you need to figure out the 0, right? Carefully. This is not 0. This is 0. 0 mark of vernier scale. Understood? So just ignore this line. You don't need that line. What you need is this one. Right. So as you can see, vernier scale has shifted. This 0 mark is shifted to this side. You can think like it is shifted to like negative side of the main scale. You can think like that. So the 0 error is negative, right? Error is negative. It makes it easier to think like that. So when there are many methods to find the 0 error, but I suggest you do this method. This is less confusing, right? So 0 error is how much this has shifted. How much this 0 has shifted to this side. Correct one is it should not be shifted, right, to any of the parts. So they should coincide 0 and 0 as external jaws touch each other. But the error is as they touch. Error occurs when those 0 marks do not coincide. So you need to find that shift. So how do you find that shift? Next step, find the coinciding point. This is the coinciding point. This point is the coinciding point. So you need to find this small length. What can we do? Let's say from here to here the length is like x or something. Let's say x. Let's say length from here to here is y. From the coinciding point to 0 marks of each. That's those lenses, right? So how many parts here? 1, 2, 3, 4, 5, 6. 6 parts. So we earlier learned each part has a 0.9 millimeter because least count is 0.1 millimeter, right? Each part is 0.9 millimeters. So we have 6 such parts in the vernier scale. So what's the value? 5.4 millimeters. 9 times 6, 54. So it is 5.4 millimeters. So let's say, see, length of main scale. So I took it as y, right? Let's see the length. 1, 2, 3, 4, 5. Each one is 1 millimeter. It has 5 parts. So it should be 5 millimeters. Understood? Then the difference of these two should be the magnitude of the 0 error. So just x minus y, 5.5. So it is 0.4 millimeters. Earlier we found that 0 error is negative, right? If this 0 mark shifted to the left side from the 0 mark of main scale, it is a negative error. It is shifted to right side, other side. Then the 0 error is what? Positive. For those 0 errors, I think everyone know how to find that 0 error. You just have to find a coinciding point, coinciding mark, then just multiply by least count. But when you get a negative 0 error, I suggest you do this method, right? What is the method? The gap between 0 to the coinciding points from each parts should be the shifted amount to the other side. So that is how we calculate a negative 0 error. So the answer here, it is millimeters. They ask the answer in centimeters, so just divide by 10. And also it is a negative value. Later you can figure out whether it is negative or positive. So the fourth one, right? Minus 0.04, it is minus, not plus. Right. 10th question. If the vernier caliper has 0 error plus 0.5, 0 error plus 0.5 millimeters, right? So if the 0 error is positive, you need to know that correction is negative. Okay. So whenever you take a measurement from that caliper, you need to subtract this much amount. 0 error should be subtracted if this is positive. So before doing the subtraction, we need to take the reading of this. So how do you find the reading? So what they ask is measurement of vernier caliper. So that is the reading, correct reading here. Right. So the first thing, what is the first step? You need to figure out 0 mark correctly. This is not the 0 edge. 0 mark is this one, right? Clearly it is drawn here. So you are doing everything with respect to this division. Okay. Right. So how do you find the reading? Reading is main scale reading plus vernier scale reading. So up to where can we get reading from the main scale? Okay, we see the 0 mark of the vernier. I think we can take readings from the main scale up to here, this point, right? This point, not this point, this point. Think about with this 0. Right, what is that? This division is what? Less than 1 millimeter, less than 2 centimeters. So it should be 1.9 centimeters. Then this should be 1.8 centimeters. Got it? So 1.8 centimeter is the main scale reading. Then you need the vernier scale reading. How do you find that? Vernier scale reading. Vernier scale reading is what? Least count times number of coinciding point. Least count, they say 0.1 millimeter. I'll write it in centimeters. So just divide by 10. So number of coinciding point of the vernier. 1, 2, 3, 4, 5, 6. This is the coinciding point. So that the value of that coinciding is 6. So what do you get? 0.06 centimeters. Then substitute it here. So what do you get? 1.86 centimeters. Got it? So the answer, it is not the answer. It is not the answer. This is just the reading. We didn't do the correction, right? So what's the correction? What's the correction? There's a 0 error, 0.5 millimeters. I'll convert that into centimeters because everything is in centimeters. So when you convert that into centimeters, just divide by 10. 0.05 centimeters. Since the error is positive, you need to subtract that from this reading. So it is 1.86 minus 0.05. 181. 1.81 centimeters. This is the correct reading. So the answer should be third one. Right. 11th question. Scale of a milliammeter that can be used to measure current up to 30 milliampere. 30. Shown by the image. When it is not connected to a current, pointer is as shown. The choice just shows both 0 error and least count in order is. Okay. So you haven't learned about milliammeters yet, right? You learned this in electricity. But from the knowledge you have currently, you can figure the this out, right? If you have a clear understanding of measuring instruments, about zero errors and all those stuff conceptually. So when this milliammeter is not connected to a circuit, meaning when it is not connected to a circuit, electric circuit, there's no current flowing through the milliammeter. You know that in O levels, right? But without a current, it shows this reading. 1, 2, 3. So it shows this reading. So this is obviously an error with the apparatus, right? So without a current, it shows a reading. So it is obviously an error. So we call this, so there's no measurement, but it shows a reading. Like in vernier calipers, right? When the jaws are close together, it shows a reading. That's an error. So that error, we call that zero error. Okay. So here also this error shows a reading without a measurement, without actual physical quantity, it shows a reading, right? So it is zero error. So before figuring out zero error, we need to get least count of this apparatus. So how do we find the least counts? So when you take the meter ruler, what was the least count? The smallest part in the meter ruler, right? So that is a 1 millimeter. So here also least count should be this length. Length of one part is the least count, right? So what's the length? So from here to here it is 10. You can take the whole thing or just a part of that. From here to here it is 10. It represents from here to here 10 milliamperes. And it is divided into 5 parts. So it should be 2 milliamperes, right? So this single part has a length 2 milliampere length. 2 milliampere value, right? So that's how it makes a 10 milliampere here. Okay, we found the least count. Then zero. So what's the zero error? From here to here it is zero error. How much is the length? 1, 2, 3. So zero error should be 2 milliammeters. How many parts? 3 parts. So it is 6 milliamperes. So as you can see here, this is a positive zero error, right? So whenever you take a measurement from this milliampere, you always have to subtract this zero error. So the answer is fourth one, plus 6 millimeter and 2 millimeter, right? These are like really important, right? When you are doing a structured essay questions, see that. So you get 4 structured essay questions from all the syllabus, right? So the first one, it could be from measuring instruments or mechanics. Second one, like optics or waves and oscillations. Third one, probably in heat. And the fourth question is from electricity, mostly, right? So that is the pattern you get questions from. So for all those 4, you need the clear understanding of these measuring instruments, right? You need to have a precise understanding of least count, vernier principle, percentage errors, those stuff. Then only you can successfully and clearly write answers for those structured essay questions. So this lesson is like really important, right? Right. 12th question. Pitch of a screw gauge is 0.5 millimeters and its circular scale divided into 50 parts. Least count of the apparatus. So a pitch of a screw gauge. Screw means it has a screw. Pitch means this gap. So that gap is 0.5 millimeters. So above that there is a circular scale. And that circular scale is divided into 50 parts actually. So what happens is when you make a turn, complete turn, what does a screw do? It just goes up or goes down. Sorry, goes down or up. So this pitch is how much does it go down or up as it turns one cycle, one circle. So to find the least count, what do? You just have to divide this pitch by number of circular parts. So this is a very common equation, right? I think everyone knows that. So the pitch is 0.5 millimeters divided by number of parts is 50. So it is 0.1 divided by 10, 0.01 millimeters. So it is 1/100th of a millimeter. So when you slightly rotate it, this goes down this much, right? So this is a very accurate measurement compared to a meter ruler and a vernier caliper. Okay, so the answer is 0.01 millimeter. It is fourth one. They ask the answer in millimeters, right? Not centimeters. If it is in centimeters, the answer is 0.001. So be careful about that, right? As you are doing questions, whether it is millimeters or centimeters. Right, 13th question. A circular scale used in spectrometer is shown by the image. Its main scale is 0 to 360 degrees, consisting of half-degree parts. Okay. So you can clearly see in the main scale, this length is a gap between these two is 1 degree. It is divided by half by a small line, right? Shorter line. So this gap is 1 degree. When you divide by half, so this is half a degree. So that is in the main scale. It is drawn clearly in the this image, right? So this is what you get in a spectrometer. So this is the only way you can take measurements using a spectrometer. You will see that this will be very useful in optics, right? So learn this carefully, right? So you can see this is a circular scale. This also has the same principle as in vernier, right? Right. So the above, it has the main scale, and this part from here to here, it is vernier scale. So what happens is you can actually rotate this one, right? Like this. Rotate this. It's a complete circle. You can rotate this vernier scale around it. You can rotate. Before doing anything, before taking the reading, you need to figure out the least count of this apparatus, right? So this also is vernier. So how do you find the least count? So the smallest measurement from the main scale is half degree. In the question they say that. Then minus 29 such parts, 29 half degree parts is divided into 30 parts. So there are 30 parts in the vernier scale. Then I am taking half out. So what do you get? 1 minus 29 over 30. Half out. So 30 minus 29, it is 1 over 30, right? So 30 times 2, it is 1 over 60. So 1/60th of a degree. So what is a 1/60th of a degree? It is a 1 minute, right? When you take a 1 degree and divide it into 60 parts, one part is equal to 1 minute actually. You have learned this in all levels, right? This is a 1 minute. These will be very useful in optics, right? See that. Okay, so what did we do first? We found the least count of this apparatus first, measuring instrument first. So that is 1 minute, right? 1 minute is the least count. Okay, that is done. Then we need to get the reading. So reading is what? Main scale reading plus vernier scale reading. Right. So when you take the reading, what's the first step? We already found the least count. Then you need to figure out 0 mark of the vernier scale. Where is that? There is 0 of vernier. This mark. Okay, so we do everything respect to this point, this line. Right. So from that 0, which value can be taken from for the main scale? If you think about that, actually this goes like from 0 to 10, 20, likewise 100, 90, 180, then 270, 350, likewise up to 360. So 360 also is at the 0 degree mark, right? So this 0, when you complete one round, from here it comes back to 360. So 360 degrees and 0 degrees is the same point, same division. So as you can see here, 1, 2, 3, 4. 1, 2, 3, 4 degrees. Up to 4 degrees you can measure it here. 4 degrees means 1, 351, 52, 53, 54. Up to 354 degrees can be measured from the main scale. Then the next one is for the vernier scale. So the vernier reading. Then you need to find a coinciding mark. In the question, they say coinciding point is this one. Actually, what is the number of that? It is 15, right? Because it is right in between 10 and 20. So it is 15. So coinciding point is 15, and the least count we found as 1 minute. So what's that? 15 minutes. 354 degrees, 15 minutes. Got it? So that's the reading here. So the answer should be third one, right? Answer should be, yeah, third one. So you need to master this measuring instrument part, right? The reason is, most of the question, if you need to score marks for structured essay part, that contains 20 marks, right? That is for doing practicals. There's a completely 20 marks. So if you master this part, easily you can gain that 20 marks. Right, 14th question. A screw gauge. Actually, this is a micrometer screw gauge, right? It has a least count 0.01 millimeters. Shown when anvil face touches spindle face. Remember those? So the screw gauge is something like this, right? Something like this. So as you rotate it, spindle touches, as we call this anvil, and spindle touches, like by rotating it you can do this like this. So there's nothing in between. So here the reading should be 0. So what should be the correct, as this happens, correct positions of 0 should be, this is the linear scale, So linear scale and 0 mark of the circular scale should coincide as this happens. But if the apparatus has a 0 error, this doesn't happen. This 0 could shift either like this or like this. Okay. So what they ask is the 0 error. So you can see this is what we call center line, right? In this line we have linear scale readings. So you can take readings up to here from the linear scale. Usually it is in millimeters, right? Then this is what you have to do to figure out 0 error. Measure respect to this center line. So what is the point that coincides with the center line? Which division? 1, 2, 3. You can clearly see 1, 2, 3. So third division, right? Third division of the circular scale coincides with the center line. Third means, so the reading should be 3 times least count, 0.01 millimeters. So 0.03 millimeters is the shifted amount of this 0. Okay, we figure that out. So to figure that out, number of coinciding division times least count. This one. Then we need to think about whether this is positive or negative. Do you see this is the 0 line, right, or center line? 0 here. This center line is above. Center line is above this 0. So center line is where you take that points to that reading, right? So you can see center line is showing a reading above 0. What does it mean? You can consider that above 0 positive, below 0 as negative. So center line is pointing towards the above point. So it is a plus, positive 0 error, right? So if the 0 error is positive, what correction should be negative, meaning you have to subtract that amount, right? So the answer should be second one there, right? Then we have a spherometer, 15th question. Spherometer with pitch 0.5 millimeter has 50 parts in the circular scale. Reading shown by the image is, okay. So first thing we'll find the least count. So finding least count is usually is better before doing anything else. So pitch is 0.5 millimeters and it is divided into 50. So 0.1 divided by 10, 0.01 millimeter. So this is the least count, right? This is the linear scale, and then you have the circular scale like this. And the coinciding point of the circular scale they mention as 40. I think you can see that, right? 20, 30, 40. Other side is 0 and 10. So this should be 40. So the coinciding point is 40. Right? So for a spherometer, also like it is the same principle as a micrometer screw gauge, but there's a slight difference, right? Above this, there's a linear scale above 0 and below 0. But for the micrometer screw gauge, it only had above 0 values in the linear scale. So usually reading is linear reading plus circular reading. So what's the linear reading here? So this has 1, 2. So up to 2 parts you can measure from the linear. And the one part should be 0.5 millimeters, right? That should be the pitch. So there are 2 parts. So the linear reading should be 0.5 millimeters times 2. That's the linear reading. If they have separated into like in half one of these, then you can consider this to be 2 millimeters, right? But here it is 1 millimeter. 0.5 times 2. So that's the linear reading. This circular reading, think about circular reading is like this, right? This is special for linear, spherometer. If this circular reading is above, if it is like this, and let's say 40, to get the circular reading, what do you have to do? Just multiply 40 by the least count. Simply just multiply like that. You can get 0.4 millimeters from that. But there's a difference when this value is below 0. You don't have to think too much about it. This is all you have to do. Just remember that, right? You don't have to think. It doesn't take further than that. So what do you have to do? So we know that this is divided into 50 parts in the circular scale. What you have to do? Number of parts divided circular scale minus coinciding point times 0 point least count. So here you are not just multiplying least count by 40, right? If circular scale below 0. If it is above 0, you just can multiply by 40. Here, if it is above 0, right? If it is below 0, what you have to do? 50 minus, if it is 100 parts, you have to subtract from 100. But since it is 50 marks, circular scale, 50 minus 40. So those are special points you have to remember, right? So this is 1 millimeter here. 50 minus 40 is 10. 10 times this one, 0.1 millimeter. So what's the value? 1.1 millimeter, right? Actually, to be more accurate, it has a further decimal point for the accuracy. So it should be 1.10 millimeters. Okay, so the answer should be first one there. Actually, this 0 is important, you know that, right? Because what does the 0 mean? The accuracy is up to 1/100th of a millimeter. That's what this 0 means, right? So in this unit, and there can be other questions as well, we usually add this 0 in order to show the accuracy of this calculation or the measurements, right? Okay, so you have to master these types of questions, right? So in this test, I have mainly covered parts that students find somewhat difficult, right?